Selamat pagi, siang, sore, malam Pak Beni. Saya Viola dan dalam video based learning kali ini saya akan menjelaskan tentang partial fractions yang merupakan bagian dari integral. So, what is partial fraction? Partial fractions are the fractions used for the decomposition of a rational expression. When an algebraic expression is split into a sum of two or more rational expressions, then each part is called a partial fraction. Hence, basically, it is the reverse of the addition of rational expressions. Just like fractions, a partial fraction will have a numerator and denominator, where the denominator represents the decomposed part of the rational function. Why do we need to learn partial fractions? In mathematics, we can see many complex rational expressions. If we try to solve the problems in a complex form, it will take a lot of time to find a solution. To avoid this, we have to continue the problem by reducing the complex form of the rational expression into the simpler form, and partial fractions is one of the examples. So, when do we use partial fractions? There are four cases that can use partial fractions. These are the four cases that use partial fractions. As long as the problem we need to solve follow one of these cases, we can solve it using partial fractions. Case 1. If the question is in this form, then we can use case 1 to solve the problem. We just need to split the denominator. So, we just need to split the denominator from the original question to two part of fractions become like this and this. Just follow from the original questions. If there are three denominators, we can just split into three. Then for the denominator, you can put A, B, C, D, E, F, G, X, Y, Z, anything you like. So how to solve it after we split it into partial fractions, we will see in the next slide along with the example. So the first example, express 2x minus 13 divided by 2x plus 1 times x minus 3. So just like in the previous, in this case, as you can see, we just split the denominator into two fractions. So here we got one fraction with denominator 2x plus 1 and another fraction with denominator x minus 3. Just like regular fractions, we need to make the same denominator if we want to add numerator. So we multiply the a with the other denominator of the fraction of other fraction as well as with b. Then we only focus on the numerator. That's why in equation we only use 2x minus 13 as the result of a times x minus 3 plus b times 2x plus 1. To solve the equation, we need to choose the appropriate value of x. To choose the appropriate value, we just need to make the denominator of the original equations equals to null, which means 2x plus 1 equals to 0 and x minus 3 equals to 0. And we just solve it just like the origin usually we solve, which means we can get x equals to 1 over 2 and x equals to 3. Then we just put the x we got into the equation and solve it like normal substitution, and we can get the value of a and b as you can see in here. Then just put the value of a and b to the partial fraction in the first step. Then we are done. Easy, right? There is also another method to solve this problem. So after we made the equation, we factorize it with the same expression as the result, which is 2x minus 13. That means the one with x we factorize together, and the one that is only number without any x, we also factorize it into 1 and solve it just like the normal equation. So as you can see, a plus 2b, it is part of x, so we compare it with the result to x minus 13, which is the one with x is equals to is 2, so a plus 2b equals to 2, and we got the first equation. Then the next equation, which is minus 3a plus b, there is no x, we solve it with equals to minus 13. Then solve it just like a normal equation, and you can get a and also b. Next is k. If we encounter the problem like this, that means it is case 2. Just like case 1, it is also the same method with only different partial fractions, which means we only made a different denominator for the partial fractions. If we encounter case 2 like this, oh, as you can see in here, we just split it into the inside of this. It become one part of partial fractions, and the other partial fractions will be the whole equation, the whole denominator. Here's the example, and this is the answer. Case 3. So if we encounter denominator like this, it means it is belong to case 3. So what we do? We put it each of this bracket into the different parts of fractions. And what makes it different from the other case is the numerator. If in previous case it is only a and also b, but in case 3 there is a, and for the other part, which is belong to cx squared plus d, you have to put the numerator as bx plus c. So how do we solve it? Similar to the previous case. You just put the x into the equation and you can get the result of a, b, and c. But in the previous case, there's only two x, right? So how do we find the other x? In this case, no. In every case of partial fraction, if there are three three answers that you need to find, but you don't know how to get the other x, that means you can just use x equals to no, x equals to 0, and you can get the results just like this. If we put x equals to 0, then we will get the c, which is equals to minus 2, and then solve it just like the previous case. So last one is case 4. If an algebraic fraction is improper, we must first express it as a sum of a polynomial and a proper fraction, and then split the proper fraction into partial fractions. So what does it mean? We will see in the example. So this is an example of case 4. It is improper fractions, right? Because we can see in the numerator 2x squared and x squared. We can see that the numerator is bigger than the denominator. Just like in normal fractions, we can call this as improper fractions. So what do? We need to make it proper fractions first, which means we just divide it just like a normal fraction, like this. Then, once you get the answer, so after we divide, we need to divide to get the simplest answer. The quotient, after we get the quotient, will be put in the equation like this. So the quotient plus the remainder divided by the divisor, which is x squared plus 2x minus 3. After we get like this, then we can solve the x minus 5 divided by x squared plus 2x minus 3, just like a normal partial fractions. Then, as you can see, the in the denominator, x squared plus 2x minus 3. So what do we now? What do we do now is to find the case that use this denominator, which means we need to factorize it first. And when we factorize, we will get x plus 3 and x minus 1. So this x plus 3 and x minus 1 follows the rule of the case 1. Then we follow. So we just need to solve it using the case 1 rule, which is a per x plus 3 plus b divided by x minus 1. And solve it just like the other partial fractions we learned before. So how do we apply the application of partial fraction in integral? As we learn partial fraction, to solve some integral questions, there are too hard to solve it or too complicated. So this is the example question. Nice. We can see that this is still hard to integral, so we're gonna do one more partial fraction with this. First of all, we factorize the denominator first so we can know which case do we use. Now that we have factorized, we can see that this follows the first case of partial fraction. Now let's make the partial fraction again. Now let's solve it. Now let's choose the x, the appropriate x. So there is 2x plus 1x plus 2. So for 2x plus 7 equals to 0, which means we can get the first x is equals to minus 1 over 2. And the second one will be x equals to minus 2. Then substitute it to this equation. Since there is not enough space, we're gonna do the x minus equals to minus 2 down here. Solve this first. Put it back into these questions. So we're gonna get so the equation that we need we just combine it with this, we're gonna get now that we have made this, what we need to do is only integral this. Solve this one by one. First of all, 2, when we integral, it becomes 2x. When we integral 1 per x, it's gonna become ln x. Now that we have 1 over 2 x plus 1, we can make it become 1 over 2x plus 1. When we integral it, become 1 over 2 ln 2x plus 1. And here is the integral. Now we just need to put the 4 and 0 into this. So when there is minus in ln, it can also mean divide. So we're gonna divide this line with this line. Just put it in a calculator. When we input it into the calculator, gonna get the answer is and so on. This is the same as 8 minus ln 9, just as like the question. So it is proven. Thank you, Pavini, for listening.